Hi, and welcome to How Do IBI, the mini-part screencast series on SQL Server Analysis Services, which is a companion to the book Smart Business Intelligence Solutions with Microsoft SQL Server 2008. I'm Lynn Langett, Developer Evangelist with Microsoft in Southern California. In this installment, we're going to take a look at implementation of dimensions for OLAP cubes using BIDS for SQL Server Analysis Services. Before we do that, we're going to talk about frequently asked questions and gotchas around dimension implementation. The first FAQ is that when you initially create dimensions, they are flat by default. And what this means is that they consist of a single level. Although for some implementations this is going to be effective, many times there will be a large number of members of a dimension, so many that it would be really impractical to expect end users to navigate. So more commonly, you will decide to create hierarchies of dimensions. And these you can think of as groupings. For example, if you were to have a products dimension with product names, you might group them into categories and subcategories. Hierarchies have two possible implementations. They can be navigational or natural. Navigational means that any two source columns can be used as grouping attributes. There needs to be no relationship in the source data in terms of the upper level having fewer members than the lower levels. An example of a navigational hierarchy could be, for example, in a customer grouping that you wanted to see the customers grouped by gender and then by geographical location. A natural hierarchy, as contrasted to navigational, is where the data does have a natural hierarchical relationship. In other words, using our example of product categories and subcategories, product names has more members than product subcategories, which has fewer members than product categories. You can think of it visually as a pyramid, and that's actually how SSAS displays it. Under the gotchas, natural hierarchies should include defined attribute relationships. The reason for this is improvement in processing and query times. When we're in the browser, we'll see how this works. Another gotcha is to build hierarchies based on existing end-user taxonomies or naming strategies where possible. This really improves usability. The other gotcha is to pay attention to any AMO warnings, which are indicated by blue squiggly lines. These should be fixed so that your cube performs in the best fashion when you load it with data. Now we'll go to the screencast. Here we are in BIDS, taking a look at the Dimension Designer. We're looking at the AdventureWorks sample, and what I've done is I've navigated in Solution Explorer to the Dimensions container, and I've double-clicked on the existing promotion dimension so that we can understand how the Dimension Creation Designer works in BIDS. We'll first take a look at an existing dimension, and then I'll show you the steps to create a new dimension. Now, when you're creating an OLAP cube, you can create a cube first, and while you're creating the cube, you can then create dimensions at the same time, or you can create dimensions first. And the method that you choose is really dependent on the number of cubes that you intend to make. If you are going to be making a large number of cubes, you will probably want to create your dimensions, which will be shared between the cubes first, and then create the cubes. If you intend to create only one cube, you may want to create the cube first, and while creating that cube, create the dimensions. So in the Dimension Designer in BIDS, we have 4 different sections to take a look at. The first one is called Dimension Structure, and if we pass our mouse over it, we can see that the description is pretty accurate. Use this to view or build or edit dimensions. We then have the attribute relationships, translations, and the browser. Let's first take a look at the browser so we can understand the structure that we're going to build. So if we click in the browser, we can see that this is set by default to a hierarchy of the promotion information. As I mentioned earlier in the screencast, the information can be displayed in a flat manner with a single level, for example, by promotion. And then if I expand it, you can see this is just simply a list of the promotions with no grouping or intermediate level shown, or it can be shown in a hierarchy if we choose to define one. And in this case, we've got a single hierarchy, promotions, and now we can see the information is grouped by a couple of different attributes, and we can expand it out and we can take a look at it. You'll also notice inside the browser we have the ability to look at different languages for which the dimensional label information might have been defined, and that's defined through the translation section of the browser here. We're going to go back to the dimension structure and take a look at the source data that's being used for this dimension. This is the DIM promotion table, which is a relational table that comes out of the data source view that was defined earlier in the project. As we could do in the data source view, we can right click here and we can explore the data, and we can go back to the data source view and make some changes if we wanted to. You'll notice that in the data source view we've got a couple of fields that have a little calculator icon next to them. These are calculated fields which are defined via T-SQL queries back to the source, so they're not stored information, they're rather produced on query. We then will select certain source columns to be used as attributes for our dimension. You'll note that we're seeing our first AMO warning underneath the dimension name, and this is indicated by a blue squiggly line. If we pass our mouse over it, we're going to notice that for this dimension we've got duplicate key errors, and it's telling us that we should not ignore these duplicate key errors. So this is an area that you should definitely fix before you process this dimension. This is showing you that your data has some integrity problems. Over in the center section here, we define our hierarchies, and these hierarchies, as I said earlier in the screencast, can be natural or navigational. And if we pass our mouse over this, it also shows that we have a possible error that we need to consider in terms of the hierarchy definition. And this error is defined as attribute relationships do not exist between one or more levels of this hierarchy. Now, it's important that you understand and remember the difference between natural and navigational hierarchies here. For navigational hierarchies, as I mentioned, you may have a situation where there are no relationships between the different levels of the data, and you simply want to browse by different attributes. And that's certainly fine, and you will get this warning, and you may choose to ignore it. If your underlying data does have a natural relationship, a one-to-many relationship, you're probably going to want to define attribute relationships. If you wanted to create a new hierarchy, you would simply drag the information from the attributes over here. You can have more than one hierarchy of a dimension. This is most commonly found in the time dimension. An example would be fiscal ordering of time information. Perhaps your fiscal year starts in July, for example, and calendar year, which starts in January. That would be shown in any cube where this dimension is used with two different groupings of that information. As I mentioned in the preview to the screencast, it's extremely important when you're capturing taxonomy that you try to build the hierarchies in a way that's intuitive for end users. One of the things that you're going to want to take a look at as well is the attribute relationships. So we're going to click on this tab, and this is new in SQL Server 2008. Really at the request of our customers so that they could better visualize the attribute relationships. And you can see here that we've got the lowest level, which is the promotion key, and we've got a defined relationship to the promotion category. Interestingly here, if we right click on the relationship itself, we can see that this relationship type is what's called flexible. And what that means is that we do expect changes in the data to occur. This is the most typical type of relationship that you're going to designate inside the Attribute Relationship Designer, and what this does is recalculates the aggregations on each process of the cube. An example of a rigid relationship would be commonly found in a time hierarchy, and that would be something like months to years, because you wouldn't really anticipate that month names or year labels would change over time, whereas perhaps your promotional categories do. So you'll notice that you have two different hierarchies here. You have promotion group to promotion category and promotion group to promotion type, and those are the ones that we had seen in the browser. As I had mentioned, if you had wanted to supply metadata for different localizations, you have the ability to do that for dimension members in the translation section here. And you'll notice here that we've got a Spanish and a French localization. You'll see that we have the caption, and then we have labels for the various level members here in the different localizations, and we also have labels for the hierarchy names. And as I had shown, if you go to the browser and you select one of the languages for which there's a localization, then that information will be displayed. I'll need to look on that Spanish from Spain. So we'll select that and take a look. Now, one thing when you're considering localizing information, When you localize the dimension information, you have to also remember that you're going to need to localize any of the measures that you've included in your cube. And that's commonly a little bit more complicated because it can involve conversions around currency. We will talk about that in a subsequent screencast around MDX calculations. Here, remember, we're just providing translations for the metadata. So there's lots more to explore in the Dimension Designer as you're working through this. You're going to want to look at the properties of the various attributes, and there are some optimization capabilities in the properties section that are important when you've got dimensions with a large number of measures. If you're wanting to create a new dimension, as with creating other types of objects in BIDS, you're going to simply select the container in Solution Explorer by clicking on it, and then you're going to right click and then click on New Dimension. You'll notice also that we have the option to select a linked dimension, and this is for scalability where you can actually run dimensions on different physical servers. We're not going to cover that in more detail at this time. So we're going to click on New Dimension, and that's going to open a wizard which is going to write XML layout, which will define the structure of the dimension. So we're going to go ahead and click Next. And you're going to see that we have some options on the select creation method for the dimension. Most normally you're going to use an existing table, and that's going to be one that you've defined from the data source view. We do have the option to generate a timetable in the data source if that information doesn't exist. You can also generate a timetable on the server. The reason for this is you might not have permission to generate tables in the data source. And here you can generate a non-timetable in the data source. You'll notice also that we have some templates, and these are part of the samples when you retrieve the AdventureWorks sample from Codeplex. So you can use the templates as well to generate an empty dimension for the purposes of modeling or having something to start with. So in our case, we're going to use an existing table, which is the most common situation that you'll have in production, and then we're going to click Next. So as I mentioned in a previous screencast, every object in Analysis Services is dependent on a data source view, so you'll have to select a data source view here. So we'll select AdventureWorks DW, and from that we'll have to select a table. Now if you follow the standard naming conventions for star schemas, which is to use dim in the name, it becomes simpler if you have a large number of tables to pick from. That isn't required, but it's a standard in the naming convention. So let's go ahead and pick something pretty straightforward here. I guess we will just stay with customer. There is a requirement that there is a key column, and it has detected that there's a primary key set up on the customer key column. You could define a multi-key column if you wanted or needed to here. Then we'll go to the next step of the wizard, and it's telling us that there is a related table that was found in the DSV and asking us whether we want to include that or not. And if we do, we just leave this checked, and if we don't, we can unselect it. And then when we click Next, it's asking us which attributes which equate to source columns in the dimension table we wish to include. So we start with the customer key, and perhaps then we want to have the last name and the birth date and the marital status. We're going to have a very simple dimension here. You'll notice that Enable Browsing is turned on by default, and we have the option to define the attribute type as regular or some other types, which include account, currency, date, and geography. These designations are attributes that are used when you're writing MDX queries that have, for example, time sensitivity. So that would be associated with a date marked attribute type. So in our case, we're going to go ahead and set birth date as a date type of dimension, a date type of attribute. And inside of here then we need to say what type of date are we, and then we can go through calendar, and we can say within calendar, is this just a general date, or is it the day of the week, the day of the year, so on and so forth. So we're just going to say date and say OK. And these can all be changed after you create the dimension. The idea is just to get up and running rather quickly. A best practice here is to be inclusive. It may seem strange, as we earlier said, that you want to be very selective in terms of data, but you can easily remove extraneous attributes from a dimension. So we find that when we build dimensions, we want to be inclusive. And then you're done. So that's all there's to it. Now, an important change from previous versions of SSAS is no attribute hierarchies are created by default. We saw earlier in the screencast that once you've completed this wizard, you go to the dimensional editor and you'll create not only your attributes, but also your attribute relationships. And those are very, very important aspects of building dimensions.